But how do we handle a system where we don't know what one of the variables equals from one of the given equations? Consider the system 2x minus 3y equals 9 and negative 4x plus 11y equals negative 3. To solve this system by substitution, we need to first solve one of the equations for one of its variables. The more challenging aspect of this problem is determining the most efficient way to do this. The fact is that we could solve for any of them, but let's consider our options, keeping in mind that we will have to divide by the coefficient of the variable in order to get the variable by itself. In the second equation, solving for the x means we would have to divide by negative 4, and fourths wouldn't be too bad to work with as fractions. Solving for the y means we'd have to divide by 11, and we don't want to have to work with 11ths if we don't have to. Solving for the y in the first equation would give us thirds, which again aren't too bad to work with, but our best option is to solve for x in the first equation, because then we only have to divide by 2, and halves are easy to work with. So let's do that now. We need to get x by itself, so first we'll add 3y to both sides to get 2x equals 9 plus 3y. Finally, we'll divide both sides by 2. Just make sure you divide both the 9 and the 3y to be fair to both sides. Now we know that x equals 9 halves plus 3 halves y, which is what we will plug into the second equation to complete the process of solving the system. Now we can use what we just found in the previous step to solve the system like we did in the first example. Since we already know that x equals 9 halves plus 3 halves y, and to find the solution we want x to equal the same thing in both equations, we can substitute that in for the x in the second equation. Once we do that, we end up with an equation that has only y's in it, so we can solve it to find the y-coordinate of our solution. First, we distribute the negative 4 to get negative 18 minus 6y plus 11y equals negative 3. Then we combine the terms with y's to get negative 18 plus 5y. Then we undo the minus 18 by adding 18 to both sides to get 5y equals 15. And finally, we divide both sides by 5 to get y equals 3. Now that we know y equals 3, we can substitute again to find x, because x equals 9 halves plus 3 halves times y. Now all we have to do is simplify to find x. 3 halves times 3 is 9 halves, and 9 halves plus 9 halves is 18 halves, which reduces to 9. Since we now know both x and y, we can give the solution 9, 3 as the point where these two lines will intersect. Now that you've seen how to use this method a couple of times, try some of the activities to solve systems on your own using the substitution method.